Thank you, Ian. Well, thanks very much for the opportunity to come and speak to you today. I'm hopefully going to try and address some of the canopy issues that you face in this season and show you potentially how technology can help. For those of you that don't know me, Precision Decisions is my own business, and I set it up on the back of practical use of the technology. We're farmers and growers in the Vale of York, and we run a commercial farm there as well. And some of you will be familiar with sort of shots like this, because this is what we're faced with on the farm at home. This is a typical crop of oilseed rape in our area. Well, it isn't, because a lot of them didn't get established. But this season particularly, in the very variable soil types we've got, then establishment has been particularly patchy where we've managed to establish a crop. So managing canopies this season, there's lots of challenges that we don't normally face. And a lot of the information that I'm showing you today is relevant, I think, to how we can potentially get the best out of variable rate technology when we've got variable canopies. It takes me back to 2001 really. Some of the data I'm going to show you is what we were actually achieving on farm with variable rate technology back in 2001 when we started doing some trials. We actually started with the technology in '98, so we've got a wealth of information behind it. If we look at where we were last season, a lot of people are very excited these days about variable rate and seed rates and all sorts of things, and people are saying to me, well, if we're varying seed rates, there's obviously no need to vary everything else because we'll have it even from the start. But what I wanted to highlight was this was one of the trial fields with the ADAS project looking at automating nitrogen management last season. And you can see we've got available nitrogen variations in one field, typically from 45 to 125 kilos of available N. And that is colossal changes. And I, as a farmer, couldn't afford myself to take enough measurements of soil with soil nitrogen measurements to understand how much variability I've got. And that's why I've always favoured a remote sensing type approach. If you look at some work that Yara have done this season, this is just looking at nitrogen losses potentially through soil leaching this season. So in October, you can see we've got 108 kilos of available N as an average across the trial sites. But when we've retested the same trial sites in January, you can see that we've got only 31. So we've lost over 72 kilos of N in the last season. So we're going to be moving into a season that is very variable for a number of different reasons. We don't necessarily know what's under a crop's feet. There's all sorts of articles in the press at the minute with people trying to say, well, it might not be as bad as we think. But the ultimate thing is that we don't really know. So how can we manage that? We're certainly going to see more spring cropping. We've certainly got two different scenarios in crops this season. So we're going to have unmanageable crops that are going to be waterlogged and flooded, that if you're anything like us in the Vale, then if it's in that situation, I've got no opportunity to knock it out, because if I do, I'll get stuck fast. And if I do get it knocked out, the chances of me getting something put back in will be very limited. So we're going to have to manage crops for the potential in unmanageable situations. We've also got patchy crops that are manageable. So we do have the potential with variable rate technologies and variable inputs to target application rates and dose rates that are relevant to a crop to achieve an optimum output. And we're going to have obviously limited establishment, the fact that we couldn't drill. And I think of all the fields that we've established, I don't think we've got more than 3, I think, that we've established the whole field in. So it's a challenging season. So how can we use technology? There's 2 distinct variants with precision farming. Do we manage to optimise or do we manage to correct? And we've often talked about optimising crops in terms of soil types with seed rates, in terms of looking at stone fractions and different aspects, so we can actually accept we're going to get a lower yield and manage a crop to that yield potential. So our inputs aren't out-wasted. We can target the appropriate inputs to the appropriate achievable outputs rather than imagining that we can achieve something that we can't. Or do we look to managing to correct? Looking to correct a problem with pH and other aspects. And this season, I think we've got those options available to us in canopy in real time, where we can actually manage to optimise a crop in the flooded area. If we think that we're going to get a small crop, then we can feed it a little bit. But if we're going to get a decent crop, then we can feed it a lot more. We can look at the yield potential. Or we can try and manage to correct in the best way we can with some of the technologies that's available. I've always fancied just-in-time plant nutrition. It's great to be able to work on historics. It's great to be able to understand the potential of a field in a previous season and to understand the good and the bad bits of a field. But when you've got very variable soil types, things aren't always standard. And what we're achieving with an average yield map is something an average over 4 years, which could have been good and bad. So having the ability to treat something in season is the thing that's always attracted me to precision farming and where I see the biggest benefits from it. Being able to supply the right product at the right rate at the appropriate time to help the crop. And there's a number of different ways we can go about that. Yara developed many years ago the N-Tester, and it's a tool that's been available for quite some years. 95, I think it was first released. And that's a little handheld tool that you can use to clip on the plant leaf, and it gives you an understanding of how much nitrogen or the chlorophyll content within the leaf. And that's something that a lot of farmers have used just as a guide in the season to try and help determine how much nitrogen to supply a canopy within the season. We took this to an extreme last season, looking at the effectiveness of being able to use the N-Tester every 3 days in a canopy. And what we did was we measured our total nitrogen applications. So we put on 68 kilos as a first pass. Then using the N-Tester, we actually applied 30 and 40 kilos. We did actually get another 50 on in here that isn't represented here. We applied 188 kilos of N last season to this canopy. But using the N-Tester as a tool to tell us when to apply that nitrogen. Using the plant to tell us when it needed it and how much it had available and how much to then apply. So we're actually using the crop for that information. And we had a threshold in here of about 660 that once we were below that threshold, as you would do with a soil moisture deficit, you would apply more water if it was irrigation. With this, it's nitrogen. And we're actually monitoring the crop growth. And you can see in March last year, we were on a negative curve. The plants were already getting stressed in March, even though they'd had 68 kilos of nitrogen. Was that a result of the fact that they'd run out of nitrogen? Well, no, it really wasn't. It was a fact that we hadn't had, at that point, any rain. And if you speak to Colin McGregor up in the Borders, he was telling you on the 28th of March last year, he was getting his irrigators ready to go. We were lucky enough to get the rainfall event, and you can see, as soon as we got the rainfall, we'd already made an application, we get nitrogen uptake. So nitrogen had been applied to the crop, but it hadn't been taken up. But we were potentially stressing that canopy. We followed the system along. We see a blip in the here. And if you remember in April, we had a mild week in April where crops went from a very small growth stage, they went through 2 or 3 growth stages within a week, and they rapidly put leaves on. And that's what the crop's representing here. You can see that the plant can't get enough nitrogen to fulfill the growth need it needs, and hence it's becoming deficient. You can see as the temperatures cool down that the plant then supplies that nitrogen back to the plant from the rooting, and then we start running out. So here's the point where we start running out of steam with the nitrogen applications we've made. So the N-Tester is telling us, or the plant is telling us via the N-Tester interpretation, when we need to start going back on. And as we pass the threshold, at the first opportunity we got when it was dry, we put some more nitrogen on. Now at this stage, we've only put on 132 kilos, and you can see that we maintained way above our threshold. We chickened out and put another 50 kilos on because I didn't believe I could grow a crop a week with 132 kilos of N. So we put another application on in here of 50 kilos to top it up a bit further. But it staggered me because when we took this to harvest, we saw, even though we'd had a 30 kilo saving on farm practice, we still actually got a 7% increase in yield. Just by applying nitrogen at the time the plant needed it, at the rate the plant wanted, without stressing that crop. And it's the first time I've ever seen a system that can work in season that I can use that can tell me when the plant is going to start needing that nitrogen and whether or not it's been effective at picking up the nitrogen we've already applied. So if we get a dry season and we've made an application of fertiliser, the plant can tell us whether it's picked that fertiliser up or not. And potentially we can maybe work out, as we get more data, how quickly it's getting that fertiliser and how much of it it's got. So it was a really fabulous tool in that sense. In some respects, this is taking precision farming to a new level because we can then start using this information, if we do it on a very small area, to use our N-Tester reference point to then start targeting nitrogen application values to other areas of the field with our N-sensor technology. So we can actually calibrate an absolute setting for winter wheat by driving to a small area in the field, learning how much nitrogen's in there, and then applying the appropriate dose to every other aspect of the field based on the nitrogen uptake measurements. So it really does open up a whole new opportunity to start accurately applying nitrogen to canopies across the season. but it gives us the benefit of knowing when to apply that nitrogen. The difficulty we have with all technologies is you've got to go through the field to test it. You've got to go through the field before you understand, is it ready or isn't it ready? With this technology, you don't have the cost of having to drive machinery across it. Crop monitoring, being able to have real-time crop sensing is something that I've always believed in. We can use crop sensing through N-Sensor as a tool to identify crop establishment, that if we are looking at variable seed rates, we can do it for the right reasons. We can make a business case for that investment. We can look at measuring the yield potential. We can actually see at emergence, more or less, the yield potential of that crop at harvest. We can manipulate the crops with growth regulators and other inputs. So this season, that's going to be vitally important. We can monitor crop emergence and hopefully we can benefit the yield throughout the season. Obviously, the benefits of being able to do this, we can increase our margins. And that will happen in two ways. We can reduce costs, which I think will be critical this season, applying the appropriate dose rate to the crop at the appropriate time. We can get better nitrogen use efficiency. Not always a reduction in fertiliser used. If we're wanting to push big yields, we still have to put more on. We can look at improving the yield and the quality of our crops. We can reduce lodging, we can reduce disease, and we can look at remote sensing as a whole new management tool to improve our harvesting efficiencies and hopefully reduce all our costs. So if you think of the opportunities that you may have with a remote sensing device like N-Sensor, we've got calibrations already for nitrogen throughout the growing season. We've got calibrations for growth regulators. But if it's got mounted on our sprayer, we've got the opportunity to collect information all the way through our growing season, from emergence all the way through to harvest. So we've got a lot better understanding and we can actually monitor what's going on. If any of you are wondering what a sensor biomass map looks like, then this is one that we've put through FarmAid, and you can see quite clearly the blue areas are representing higher crop growth, the red areas are representing poor crop growth, and you can see I've got two fields here. If we compare that to a combined yield map from a totally different system, you can see that the trends are virtually identical. So the sensing technology is very, very good at being able to predict early in the season the potential of that crop come harvest when we get there. So you can see quite clearly that the trends where we've got areas of very heavy soil, low yield, areas of very light land in this particular case, showing us the pointer's not working, showing us a higher yield. How do we manage it in canopy? We've got the ability to start varying inputs for a number of different reasons, and we've been challenging people this season to think about that in a different way, looking at variable nitrogen applications to try and improve tillering, to try and get us more ears at harvest. If we haven't got enough plants, then we can try and hopefully, if we're not too late already, get that nitrogen on. And what I want to point out here is the benefit. We've applied 220 kilos to all these treatments, so they've had the same total amount of nitrogen. All we've done in this instance is change the splits. So we've looked at 40 kilos early, 100 kilos early, and then counted the tillers. Thanks.
You have to use that one to turn it on, but that's the point.
Do what?
That one will point.
Yeah, okay.
And that one will move on.
Okay, thanks, Ian. So you can see here, at standard farm practice, we've only got one tiller. But by applying 100 kilos of nitrogen, we've managed to increase that to 2.5 at 200 seeds per square metre, up to 3.5 at 100 seeds per square metre, taking us up from 300 ears up to potentially 400 in there to 550 and 450, an extra 150 plants per square metre. Oh, not plants, but ears. When we look at that in terms of yield, then the benefit of having those extra ears at harvest, provided we could sustain them, was an extra nearly 2 tonne a hectare, 1.8 tonnes per hectare. So in terms of a yield advantage, there's a significant yield benefit from making those backward areas where we're struggling with emergence to till them more profusely and then hopefully give us more ears at harvest to improve that yield. The only difference in that trial was the amount of nitrogen we applied. All the timings were identical, and it was just the splits of nitrogen. But you can see the potential that you've got with nitrogen as a management tool to start targeting inputs to canopies to try and develop and improve the yield performance. We often get asked about how we can use N-Sensor for other aspects, and this is an example in Sweden where they use it for fungicide spraying, applying a higher dose rate of fungicide to a higher canopy. So the thicker the canopy, the more fungicide, the smaller the canopy, the lower the fungicide. In this case, it was developed for mildew applications. But we can take that a stage further. and we can look at looking at it with growth regulators. And in a similar sort of season, back in 2001, I did some work with Syngenta looking at variable growth regulator applications with the end sensor. So in this particular case, all we varied was the growth regulator. But it really opened my eyes. We were looking at the ability of the sensor technology to be able to predict the lodging potential and then target appropriate dose rates of growth regulator. And we got some good results. We looked at variable applications between flat rate, variable rate, half rate versus flat rate versus the variable rate. And what we actually saw, sorry, I think that's my phone. What we saw was we were varying at the time with Modus being a new product, 0.3 of a litre and 0.185 of chlormequat. Half rate was 0.2, 1.5, and with the variable rate we went down to anywhere down to 1.1 a litre of a hectare. I'm sure that you'll all be frightened to death by those rates today. When it came out, we were learning. But what we found was quite staggering. We monitored the biomass of the system of each plot through the thing, and you can see that we've had good effects all the way through. There's been no significant changes. So we weren't stressing the canopy too much. We couldn't really draw any conclusions from the biomass data, but when we took it to yield, we did see a big benefit. I'm getting my lefts and rights the wrong way around. There was a very close correlation. The trends that you can see on the graph that's hidden at the back were very close to what we saw in the biomass. But what we actually found with this, the bit that astounded me more than anything else, was that where we put high dose rates of growth regulator at farm practice in backward areas of crops that we've got this season, then we were suppressing yield significantly. If you've got a stressed plant that's trying to grow, the last thing you want to do is put something on it that stops it growing more. So the growth regulators were causing us a yield loss because in the season that we were using them in, they were having an adverse effect on yield as opposed to reducing lodging when the lodging risk wasn't there. In this particular case, we saw a yield advantage of 0.18 tonnes per hectare. And we saw a variable rate margin at the time of £18.73. That maybe needs modifying into today's. But the biggest improvements in yield were always in the backward areas of the crops, which made me start thinking about this season again. We've looked at this before in other trials we've done, where we've had no PDRs. And what I want to just get you to think about here, forget the fact that we're varying things. Look at this. Our no PGR treatment plots had the lowest number of established plants per square metre. They were the highest in terms of canopy size. So growth regulators do have a crop height reduction effect. You'd be pleased to wear, but I'm sure that's not a revelation to you. You can see when we counted the established ears at harvest, we had the lowest number of ears on the no PGRs, which makes sense if you've had the lowest number of plants. We've made variable applications, and this was the trial field we were using. You can see where we've actually varied the rates, where we've got exceptionally lush areas in a valley bottom versus weaker areas on a chalky hillside, and you can see how the technology's had the ability to respond to that, in this case using direct injection. The bit I really wanted to point out here was the no PGRs. Lowest ears per square metre, lowest ears per square metre, but it isn't the lowest yield. And that's the effect that growth regulators are having on those backward areas. They're suppressing yield and suppressing growth. So it's something certainly that you can think about this season as a real opportunity for variable rate would be variable growth regulator application. Agricon are a partner company that we work with in Germany, and this is some of their trial results. They've been doing variable growth regulators a lot longer and have a growth regulator module within the end sensor. They would claim yield response is 0.1 to 0.3 tonnes per hectare, a reduction in growth regulator use between 10 and 30%, reduction in lodging, but benefits in margins between 25 and 44 euros per hectare. So you can see that it's not just here we have the same effects. If we look at potentially then the combination of the technologies, when we've often explored variable rate, to prove a concept, it takes quite some time because we've got to prove it's the growth regulator having the effect, not the nitrogen. So everything else has to be flat rate. So if we look at combining the technologies and see the synergies when we start getting the benefits of variation between both of them, this is the trial's results to show that. So here we've got constant nitrogen and constant PGRs. We call it our 100%, that's farm practice standard. If we look at variably applied nitrogen, we typically get our 2.5 to 3.5% yield response without a lot of problem. In this case, the growth regulators are constant. If we look at variable rate growth regulator, then we use less growth regulator and see a small increase in yield. But where we combine the two, where we use variable nitrogen and variable growth regulators, it allows us to promote growth in backward areas of the canopies without stressing that canopy, and then allowing more nitrogen to be more nitrogen uptake to occur, and then improve the yield. But with also a bigger reduction in growth regulator use. So you can see that we've used less growth regulator and significantly increased yield. So over and above both applications. So there's a synergetic effect between the two of them. I often get asked what happens if you do everything. So this was a field back in 2001 that we had done this on. And we, in this case, using the technology, using my experience, and using computer software to help us manipulate and apply chemicals. So we knew exactly what we were doing. So we were collecting the sensing data while we were doing our normal applications of nitrogen. We were taking that map of information and converting it into an application plan to apply growth regulators, because at the time we were using solid fertilizer and the sensor was on top of our spreader, not on our sprayer. You can see that when we first started that we had quite a variable canopy. You can see there was an old field split there, and you can see clearly where the old fields were. You can see where the wet hole where we got poorer establishment was. But you can see is with the biomass maps as we go through the season, the effect that we've had at evening the canopy up when you compare the canopy maps. The different applications, you can see where we've reduced growth regulators for the backward area, where we've put more growth regulator, where we've got a higher lodging risk. You can see where we've perhaps looked at more nitrogen, where the canopy is backward, but not overdoing it in areas where it's small, applying an appropriate amount rather than too much. What we saw was in some cases we were spending 35% more on inputs than we would have done at farm practice. The minimum spend was 60% less than we would have done at farm practice. And a preliminary saving across the whole field is an average of 10% on our inputs. What we saw with that was a benefit in terms of cost savings of £9.75 a hectare, with a yield benefit in that field of 0.67 tonnes per hectare, which gave us a total yield benefit of £120 a hectare. When we combine the two with the savings, obviously then it's £131.25p per hectare. At the time when I did this, the yield responses were small, and wheat only being worth £60 a tonne, the figures didn't seem that good. But when you see it today, under the current conditions, a small advantage in current pricing today, a small advantage in yield will pay back you big dividends. So there's big advantages to be had from variable rate applications this season. We also look at variable rate seeding. Big fan of variable rate seeding, but for the right reasons. Don't just do it because you can do it. Do it because it's a business case for doing so, and understand why you're doing it. In this case, we were looking at soil conductivity measurements, but not in its own. If I'm going to vary seed rates, I want to do it for the right reasons. We've got heavy areas on here versus lighter areas. Is the heavy soil actually reducing yield? In some cases it will. In other cases it may not. This is a sensor biomass map showing us the emergence. So the sensor's putting a third dimension to this. It's allowing us to see the emergence of our canopy and how the crops are actually performing in those different soil areas. And even though we are heavy all along the top, you can see there's areas that still emerge quite well. So do we really need to be thinking about that if we get decent emergence on those areas? Is it worth changing the yield, changing the seed rate? Well, then we've got a yield map to prove that yield is being limited in areas that we know plant populations are restricted, but not in the areas where it's emerged quite well. So we can make a true business case for our seed rate applications as opposed to just assuming it's a soil type effect. We can create a variable prescription map to then variably apply our seed based on the variances we see in the canopy and on the soil. So we're reducing it in areas where we know that the soil's lighter, but in some cases where we know we get poorer emergence because of the end sensor data, we can actually maintain the seed rate. And what you can't see on here is that all this side here is shaded by wood, and that area there is often shaded and doesn't get emergence as quickly because the soil doesn't warm up, because it's often that bit that's still frosty in the afternoon because the sun hasn't shone on it. So if we based it just on soil, we wouldn't know that. We then take this to yield. Well, we drill it, obviously, before we can take it to yield, and just using standard drill technology with as-applied data to prove what we've done and where we've done it and that it's all worked accurately. We can then scan it during the season. And this is, again, an end-sensor biomass map showing you the results of the application and the influence of the variable seed rates. And you can see we've had a very good effect at evening it up. The area that was very forward isn't as forward as it was the season previously. The area that's backward, where we've had the poor emergence, we seem to have managed to increase that quite amicably. Interestingly, even though this is done in November, you can see an area in here that's showing a lower response to the crop back density. We can take this to harvest and yield map it, and we can see a yield map showing us the variability across our field. We've still got some waterlogging issues that cause that, and irrespective of what we've done with seed rate, our next issue is the waterlogging that we need to resolve to stop it killing it. But you can see we've got a far more even yield across the whole field. This area still sticks out though, isn't that weird? When you compare these two fields, this is a farm practice versus variable rate. Variable seed, variable nitrogen, variable growth regulators versus flat rate. 3 tonne per hectare yield difference between the two because we're applying the appropriate dose at the appropriate time. That field also had to have an extra 2 doses of slug pellets because we didn't get the slugs on top of the slugs properly and because the emergence was quite poor. So you can see the benefits really that variable rate technology can have. If we start taking our data a stage further, you can see that we've got the ability to start targeting inputs and targeting our questions and research. So rather than looking at just areas on a grid basis, let's look at the areas of limitation and come back to identify those areas and do some soil analysis. And look what we find when we start using the yield data and all the other data to the full of its potential. We've seen a limitation all the way through the grain season. It's represented in the yield map. Let's go and identify and go back to our original concept. Do we manage to correct or do we manage to optimise? In this case, with a pH of 5.5 in that area, we can optimise that by applying lime. We can correct it. So there's big benefits. If any of you wanted any information, then that's where you'll get me and our website. And that's about all I've got time for.